Welcome to the deep dive. Today we're unpacking something pretty central to blockchain, this paradox, really. You have this radical transparency, which is, the whole point for verification, but that very transparency, it's kind of the fatal flaw keeping big institutions away. I mean, you can't just ask them to splash their trading strategies or private data onto a public ledger for everyone to see.
Exactly right. It's not just about regulations, it's baked into the design. It blocks potentially trillions in assets from public chains. And that's where Zama comes in. They're tackling this head on. But look, they aren't just selling privacy. That's not the frame. They're building fundamental infrastructure using fully homomorphic encryption, FHE. It's about enablement, enabling things that weren't possible before.
FHE, right? That term gets thrown around a lot, the holy grail of cryptography, people call it. But for listeners, maybe break it down. What is FHE in simple terms?
Okay, yeah. The analogy I like is the lockbox. Imagine a transparent box, it's locked tight. FHE lets you do calculations, complex ones, on the data inside that locked box. Yeah. Without ever having the key, without ever opening it.
So the data stays encrypted the whole time, even while it's being worked on?
The whole time. From your device, across the network, during computation, all the way back. It's protected while it's actually in use.
Okay, if it's so powerful, the holy grail, why has it been stuck in academia for so long? What was the bottleneck, the thing stopping it?
Yeah, the bottleneck was, well, it was just too slow. Impractical. See, every time you compute on encrypted data, you add a bit of cryptographic noise, like static, too many computations, too much noise, and poof, the data gets corrupted. You can't read it anymore. Previous ways to sort of reset that noise, they were incredibly slow, killed performance.
Ah, okay. So Zama cracked that.
That's the breakthrough. They use an implementation of TFHE and this technique called programmable bootstrapping. Think of it like fine-tuning an old radio dial. It cleans up the static, resets the noise really efficiently, and crucially, it allows for, well, basically infinite computations without drowning in noise. They made FHE fast enough to be practical.
That's the cortex sorted then. But how do you get developers, everyday Web3 coders, to actually use this complex stuff?
Right. Strategy. That's where their FHE VM comes in, the fully homomorphic EVM.
Building on the Ethereum virtual machine, not some new proprietary thing. That seems smart.
Wow.
Why the EVM specifically?
It's all about distribution. Getting it out there. Forget technical purity for a second. They let Solidity developers who are already building on Ethereum create confidential contracts just by changing a data type. Like instead of EN32, you just write EN32. That's it.
E for encrypted.
Exactly. All the hardcore crypto gets abstracted away, lowering the barrier to entry to practically zero.
Wow, okay. And the impact of that. That's where the big money, the institutional interest really kicks in, like take DeFi.
Oh, absolutely. In DeFi, this is huge. It basically kills front running. And MEV, maximal extractable value. Right now, bots see your trade in the public mempool, jump the queue, make a profit off you. It costs users billions.
Yeah, everyone hates MEV bots.
With FHE, your transaction details what you're buying, selling, the price, stay encrypted until the moment of execution. No information leakage for bots to exploit. It removes that whole predatory layer.
Okay, that's DeFi. What about the institutions, the RWAs, real-world assets?
Same principle. Institutions can finally tokenize assets, trade them on public chains without revealing their entire portfolio or their secret SOX trading strategies. That's been a massive blocker for them. FHE unlocks that.
In Zama's vision, it seems even bigger than just crypto, right? They talk about HTTPZ.
Yeah, that's the grand vision.
Yeah.
Think about how the internet went from insecure HTTP to encrypted HTTPS for secure browsing. They see FHE as the next step, the foundation for HTTPZ, a zero-trust internet,
Right.
where end-to-end mathematical encryption is just the default for everything, on-chain, off-chain, the whole web.
Okay, it brings up a comparison. How does this stack up against other privacy tech? People talk about hardware solutions, TEs, like Intel SGX. Zama uses FHE for the data secrecy, right? And I think they combine it with ZQC's zero-knowledge proofs for verifying computation.
Correct. FHE hides the whats, ZKPs prove the how, without revealing the what. They're complementary.
Right.
But comparing FHE to Ts, that's a really fundamental difference. It's math versus hardware.
Explain that difference. Why does it matter?
Okay, with a T, like SGX, you have to trust the hardware manufacturer, Intel in this case. You're trusting that their chip is secure, that there are no backdoors, no vulnerabilities, no side channel attacks that could leak your secrets.
And history shows those things do happen.
They do. With FHE, the trust model is minimal. It's based purely on public, verifiable mathematics, the cryptography itself. For high-stakes applications for institutions handling billions, that mathematical guarantee, it just fundamentally stronger, more robust than a black box hardware assumption.
Right. You can audit the math. You can't easily audit the silicon for hidden flaws.
Precisely.
So Zama's position is really as the foundational layer. They're becoming the Intel inside for FHE, aren't they? Powering other projects.
Yeah, absolutely. You see projects like Phoenix, Inco, major LTs and L3s, they're building on top of Zama's core FHE libraries.
Yeah.
Zama provides the engine.
They're enabling the enablers.
Exactly, solving that core infrastructure piece for the whole ecosystem.
Okay, so wrapping this up, where does this leave us?
Well, here's the provocative thought. Zama's aiming for, I think, 10,000 transactions per second using dedicated hardware accelerators they're helping develop. If they hit that kind of speed, it does the main argument against FHE that it's too slow just to evaporate. And speed isn't the issue anymore. Does purely mathematical security become the undisputed default standard for all sensitive data, online, on-chain, everywhere? That shift to a universal zero trust foundation, that could fundamentally change everything about how we handle data.